Differentiation of logarithmic functions. By logarithmic functions, we are only specifically talking about ln x or ln of whatever function it is. We do not do log base anything else, okay? But log base e, which is what ln is. So if you differentiate ln x, you get 1 over x. If you differentiate ln ax plus b, you will get a over ax plus b. Now, what is the logic here? Now, this two you can memorize, but you're not just going to get this kind of questions, but you're going to get all sorts of stuff inside here, right? Which is some function of x. So we are going to have to generalize this so that you can apply it to any kind of function thrown at you. And basically what you get is the differentiation of ln fx is equals to, you put the original fx in the denominator, and you differentiate the fx, you put it in the numerator, okay? So this is the d dx of fx. And in textbook terms, we call this f prime x, which is the differentiation of fx over the original fx. F prime x over fx. So this is the catchphrase that we will always use to kind of remind ourselves what you have as a result of differentiating ln of fx. Example 3, differentiation of logarithmic functions. So we're going to differentiate this. If you differentiate d dx, the ln of 5x squared plus 7x. Okay, differentiate 5x squared plus 7x, you get 10x plus 7 over the original, which is 5x squared plus 7x. So, okay, not bad, quite easily done. Part B, if you differentiate d dx ln of cosine 3x, that gives us, differentiate cosine is negative sine 3x, and you multiply that by 3, isn't it? Because you differentiate the angle. Then we divide it by the original, which is cosine 3x. You're expected to simplify this, and by your trigo identities, you know that sine 3x over cosine 3x is actually tangent 3x. So here we have negative 3 tangent 3x. Part C, if we differentiate the ln of the cube root of x squared plus 5, okay? We can write the cube root as the power 1/3. Now, before you're going to do chain rule and all that, you know, you can do that, but we won't, because it is a much easier way to deal with this. And it's to say that the 1/3 power you bring down using power law. So I'm not going to differentiate just as yet. I'm going to d dx, okay? I'm still writing this, that means the differentiation hasn't been taken place yet. 1/3 of ln x squared plus 5. Yeah, now I differentiate, I have a much easier time. And we say that this is 1/3 of f prime x over fx, which is 2x over, differentiate x squared plus 5 is 2x, right? And you got x squared plus 5 in the denominator, okay? So if you write it properly, this is 2x over 3 bracket x squared plus 5. Alright, part D, we're going to differentiate log base 5 of x cubed. Now, as I mentioned earlier on, we do not differentiate, at least for O-level math, we do not differentiate log of any other base than log base e, which is ln. And so we can't differentiate this directly, we have to do a change of base law. And we are going to have ln of x cubed over ln of 5, okay? We use the change of base law and we get ln here now. Now, if you think about it, this ln 5 here is actually a multiple. So we can say that this is 1 over ln 5 times ln of x cubed. And we know that when you have multiples, they don't get affected by the differentiation. So we're just going to leave it. Okay, I haven't done the differentiation yet, so I'm just going to have to write the d dx still. Now, if you want to differentiate straight from here, you can. However, we can do a little bit more simplification before we do, because you notice that this x cubed here is power 3. And the power 3 can be pulled down using the power law. Okay, so I'm going to pull this power 3 to the front. I still have yet to differentiate. So I write d dx of 3 over ln 5 times ln x. So now, this is the only part that requires differentiation. Okay, the 3 over ln 5 is just the multiple in front, and we just leave it alone in the differentiation process. Differentiate ln x is 1 over x, or if you want to go step by step, differentiate x is 1 over the original, which is x. So we have 3 over ln 5 times x, right? Now, if you write 3 over ln 5x, it's very confusing. Is it ln of 5 times x, or is it ln of 5x? Okay, and in this case, if you write ln of 5x, it's wrong because it's actually ln 5 times x. So I'm going to write it as 3 over x ln 5. Okay, I don't have to use brackets, and it's very clear. X is multiplied to ln 5. Part E, differentiate ln of the square root of 2 plus x over 2 minus x. So again, you can see that the square root here is power half, and we can actually simplify it first. So we have the d dx of ln of this whole thing to the power of half, right? So by now you should know, I hope you do, to pull this power half down to the front, and you have the d dx of, still yet to differentiate, half ln 2 plus x over 2 minus x, sorry. This is minus. Now if we carry on the differentiation from here, you realize that you have to do quotient rule, and that's a lot of effort, right? So we don't want that, and we can actually circumvent that by actually splitting up these two, because in laws of logarithm, we have two expressions divided that's taking a ln. You can actually split them up using quotient law. Okay, not quotient rule, but quotient law under logarithms. Okay, so we have half here times the ln of 2 plus x. Divide, you get a minus. Okay, and then you have a separate ln term here, 2 minus x. Yeah, so we split this into 2. And yes, we still have yet to do the differentiation, so I should just write the d dx here. And then we do the differentiation. We're going to have a much easier time. So we will have half of bracket. Differentiate ln 2 plus x is 1 over 2 plus x minus, differentiate this, you get a negative 1. So negative is positive, right? So you get a 2 minus x here. Yeah, that's it. Okay, maybe I should just break it down, right? This is negative here, and then you differentiate negative x, you get negative 1. Then minus is plus. Okay, so 1 over 2 plus x plus 1 over 2 minus x. So when we look at these questions, we realize that for the differentiation of logarithmic functions, there's a lot of times that we can actually use product law, quotient law of logarithms to split them up and to simplify the expression first to make the differentiation easier. So now it's your turn to try. Check out the questions coming up and leave answers in the comments below. Depending on where you're learning this topic from, you can have a much bigger variety of questions than what we shared here. Okay, so what we have here is just scratching the surface. It's meant to just get you to start off on this topic, understand the concepts. You're going to have to do a lot more practices to be good and be scoring A's. Share with me what questions you have in the comment section below, and maybe I can help you out with the homework a little. Alright, so that's it for this video. Like and subscribe. See you next time.